The boundary element method. A relatively new technique for numerical solution of partial differential equations is the boundary element method, BEM. There are no interior elements. Rather, all nodes are placed on the boundary of the domain. In this case, there are no interior elements. All nodes are placed on the boundary of the domain. All nodes are placed on the boundary of the domain. The element is a small piece of boundary surrounding the node. As this picture. All nodes are placed on the boundaries as shown in this picture. The element is a small piece of the boundary surrounding the node, as shown here. The strength of the element can be either constant or variable. So let me write the strength of the element can be either constant or variable. For plane potential flow, the method takes advantage of the particular solution. For plane potential flow, the method takes advantage of the particular where psi star two pi on which satisfies Laplace equations, the dual psi equals to 0. Each element I is assumed to have a different strength psi I. Each element as shown also in this picture. each element has the psi then R represents the distance from the element to any other point in the flow field. This R. Let me write, and also in the picture again. R represent the distance from the element to any other point in the flow field. To any other point in the flow field, summing all these elemental effects with proper boundary condition will give the total solution to the potential flow problem. At each element of the boundary, we typically know either the value of psi or the value of at each element of the boundary we typically know either the value of psi or the value of where n is normal to the boundary. The correct strange psi I are such that these boundary conditions are satisfied at every element. We now at each point the correct strange psi I are such that these boundary conditions are satisfied at every element. Summing these effects over n elements require integration by parts plus a careful evaluation of the effect of element I upon itself. The mathematical details are also available in some references. And the final expression is for each point the psi quantity can be obtained as this expression. On psi star on rho n ds to n round n j ds I equals to 1 to n. The integrals which involves the logarithmic particular solution psi star from the equation are evaluated numerically for each element. These equations contain two n elements, values psi I and let me write two n element values and solve of which n are known from the given boundary conditions. The remaining n are solved simultaneously. For 2n n now from the given boundaries and n should be calculated from solved simultaneously from equations from the solved from these equations. Generally, this complete the analysis only the boundary solution is computed.